to all of you. Myself Sharvan Kumar, Assistant Professor at Ajay Garg Engineering College in Department of Computer Science and Engineering. My today's topic is sorting in C, and we will discuss one important algorithm, that is bubble sort. So that is a part of our subject PPS, which is included in Unit 4. So first of all, what is the meaning of sorting? Sorting is the process of arranging the element in particular order. So the order may be ascending or it can be descending order. So the advantage of sorting is effective data accessing. So there are two types of sorting. One is internal sorting and second is external sorting. When we talk about the internal sorting, internal means if all the element or records to be sorted are in the main memory, then such type of sorting is known as internal sorting. When we talk about the external sorting, if some of the elements to be sorted in the secondary storage or disk, such sorting is known as external sorting. So there are types of sorting technique. First is bubble sort, most important and most commonly asked in the questions. So first is bubble sort, second is selection sort, third is insertion sort, fourth is quick sort, merge sort, heap sort, cell sort, radix sort, and address calculation sort. So we will discuss first one, bubble sort. So efficiency of sorting technique. So how to select sorting technique for a given set of element. There are number of sorting technique available to sort a given array of data item. So each sorting technique has its own advantage and disadvantage. So different techniques are useful in different applications. So there are three most important factors are counted while selecting a sorting technique, which are number one, coding time, the amount of time invested in writing full length sorting program. Second is execution time. We talk about the time complexity, the amount of time required to execute the sorting program. So this normally frequency of execution of statement in a program. So the number of time statements are executed. Third one is memory requirement. Memory requirement means space complexity, the amount of memory required to store the entire sorting program in the main memory while execution. So analysis of sorting technique. So that depends. First, the analysis of sorting technique depends on three factors, which are code, time, time complexity, and space complexity. Among these three factors, while analyzing a sorting technique, we mainly concentrate more on the time complexity. Next, the time complexity is the amount of time required to execute the sorting program, which is analyzed in terms of three cases. So these cases are best case, worst case, and average case. If I talk about the best case means how efficiently, how we use this sorting technique, means best case. Worst scenario, how much worst time it will take, the average time in between these two. So we talk about the most important algorithm, that is bubble sort. So bubble sort, it is the most popular sorting technique among all the techniques because it is very simple to understand and implement, and it also called exchange or sinking sort. So working of bubble sort says the algorithm begin by comparing the element at the bottom of the array with the next element. If the first element is greater than the second element, then they are swap or exchange. So this process is then repeated for next two elements for second and third element, after n minus 1 comparison, the largest of all the data items bubble up to the top of the array. So the first n minus 1 comparison constitute time pass, first pass. During second pass, number of comparison is less than the previous pass. There are n minus 2 comparison in the second pass. During the second pass, second largest element bubble up to the last one, but no, but one position. So consider the following array. A, we have 5 elements, 30, 10, 5, 20 and 50. So this array name which say it is A, that is the position A0, 10 is A1, 5 is A2, at A3 the element is 20 and A4 element is 15. Now begin the sort by comparing first two element, means first two element, this one and this one. Compare these two. When we compare these two elements, the first element is greater than second element. So that exchange will be take place. This exchange will be take place. So after the exchange, the now array becomes 10, 30, 5, 20 and 15. One more important thing, only these two elements will interchange and no effect on other elements. Now compare second element with third element. Check which one is short, which one is greater and which one is lesser than this one. So we see here 5 is lesser than 30. So swap will be take place. So interchange this thing 10, 5, 30 and 20. Now compare 30 with next third element with fourth element. When we compare, we see 20 is lesser than 30. So swapping again will be there. After the swapping, 20 will come here and 30 will come here. Again, we are going to compare 30 with 15. Fourth element with fifth element. So once we compare these two elements, what we get, the element become 30 will be at, means higher element will be on last element. In first, that is the pass 1. That is the pass 1. That is in pass 1. One pass is complete and we get our first largest element. Now in pass 2, again we are going to compare these two elements, first two elements 10 and 5. We see 5 is lesser than 10, so interchange will be take place. Now after the interchange, 5 will be placed at first position and 10 is the second position. Again we are going to compare 10 with 20. We see 10 is lesser than 20, so no interchange will be there. So we will get same as it is. Again we are going to compare 20 with 15. After this change, interchange will be there. So we will get 15, 10, 20. Now our 30 at correct position, and now we are getting second largest element at second position. So no interchange after that. So that is completing of pass 2. So after this thing, again check for first and second element. Now compare these two, both are at correct position. So next no interchange will be there. Again compare 10 with 15, no interchange will be there. Next, that is pass 3. After pass 4, the third largest element will be there, and next second largest element is already on pass 4. Last one is we are getting the sorted array. We are getting the final sorted array after n minus 1 passes. So algorithm is bubble sort algorithm. The algorithm sort a given array an using bubble sort technique. Variable I, j used for index. The array and temp is the temporary variable. So in step 1 we are going to start. Next, step 2, input the array an. After the array inputting, now compute the sorting. We are going to step for pass. We are going for pass. So we will repeat our loop I0 to n minus 1 because it takes lesser than 1 total size of array. So that is n minus 1. So repeat. We are going to compare j means interchange of within that array j 0 to n minus I minus 1. So if in that nested loop, what we are going to compare first element with next consecutive element. If that is lesser or greater, then we have taken the temporary variable and first element will be compared to transferred to temporary element, and next consecutive element will be transferred to this one, and temporary element will be transferred to this one. After this loop, we are going to repeat this for j up to n minus I minus 1. So after the end of the loop 3 and after the end of loop 4, what we are getting? We will display the output and repeat I0 to n minus 1, and we are going to output the array I and end for loop, and we are going to stop that algorithm. So that was our algorithm. Now analysis of this algorithm. Analysis algorithm says the best case. If the given array of is in ascending order, the outer for loop will be executed n minus 1 time. So the inner for loop and if statement will be executed n minus 1 time. For the first iteration of the outer loop for loop, n minus 2 time. For the second iteration of the outer loop for loop, so on. So one during time n minus 1 nth iteration, the outer for loop. So interchange part will be executed even once. If I talk about the worst scenario or worst case, if the given array is in reverse order, so the outer for loop will be executed n minus 1 time, and the inner for loop, if statement and interchange part will be executed n minus 1 time. The first iteration of the outer for loop n minus 2 time for the second iteration of the outer for loop, and so on. Only one time during the n minus 1 ith iteration of the outer for loop, hence the maximum number of comparison and interchange operations will be there. So advantage of bubble sort is it is very simple to understand and implement, very straightforward, better than selection sort. Now if I talk about the disadvantage, it runs slowly and hence it is not efficient, because more efficient sorting techniques are available. Even if arrays sorted in n-1 comparison are required. We run the its bubble sort program. Here we are taking the array ARR with element 100 elements we are going to take as an input. We can take up to 100 elements. We can take up to 1000 also, but a sufficient number is we are going to take. I, j are for loop, n is the number of element, temp is the temporary variables. Now in line number 7, what we are asking for number of elements, and user will input for number of element n. Next we are taking integer I. We are initiating our loop to input the array for 0 to n, and we are going to input that array elements. After that, we are going to use our for loop, our bubble sort algorithm steps. So first is our for pass 0 to n minus 1. Next we are going to use 0 to n minus I minus 1. Now we are going to compare array of a of j with array of j plus 1. If that is true, in that case array of j will be transferred to temporary variable, and array of j plus 1 will be transferred to array of j, and then temporary variable will be transferred to array of j plus 1. After that we are going to sort the we get the sorted element, and now we are going to print that element. For that we will use I equal to 0 up to that n number of elements, and we are going to print that array. Let us execute this code. No error. Run that code. Enter the number of element. We take 5 elements. Number of elements 30, 15, 20, 5 and 10. What we are getting? Our sorted element. If already we are going to use this thing, 7, 1, 2, 7. Already sorted element we provided, that already sorted is there. That is our best case. If I talk about the worst scenario, 6 elements we are going to take, and that is 98, 95, 94, 91, 88, 75. That is our worst scenario case, and that is our running of this algorithm. Thank you very much.